Lecture, Module 8, The Enduring Importance of Greek and Latin in the Sciences. We'll explore a topic crucial for anyone pursuing a career in the sciences, the importance of Greek and Latin. These languages are tightly integrated into the core of scientific disciplines. Ancient scholars who wrote in Greek or Latin laid down the foundations of many scientific disciplines. Consider Aristotle, not just the greatest philosopher, along with Plato, of the past, but also the originator of the scientific study of life. Or think about Euclid, whose Elements laid the groundwork for geometry. Their works were written in Greek. Later, during the Renaissance and into the early modern period, Latin became Europe's dominant language of scholarship. Scientists like Copernicus, Kepler, and Newton wrote in Latin, the universal language of science. This meant that their discoveries could be shared and understood across Europe, transcending national languages. Latin remained the lingua franca of scientific and intellectual discourse well into the 18th century. Even as national languages began to dominate other forms of writing, Latin continued to be used in scientific publications. This established a tradition where scientific ideas could be communicated across different linguistic communities, fostering a shared body of knowledge and a sense of unity among scientists. One key reason Greek and Latin are so important in science is their ability to convey meaning with precision and clarity. Scientific terms often derive from these languages because they provide universally recognized roots, reducing the risk of ambiguity. For example, consider the word biology. It comes from the Greek words bios, life, and logos, study. This term is clear and descriptive, immediately communicating the essence of the field. The same goes for astronomy, astron equals star, nomos equals law, which tells us this field is about the laws governing stars and celestial bodies. Latin is essential in disciplines such as biology, botany, zoology, microbiology, paleontology, and entomology because of the system of binomial nomenclature developed by Carl Linnaeus. This system assigns a unique Latin name to each species, serving as a universal identifier. For example, the Latin name Homo sapiens refers to humans, while Helianthus annuus identifies the common sunflower. Using Latin, scientists and botanists worldwide can communicate about species consistently, regardless of language differences. Latin terms also prevent confusion from common names, which vary across languages and regions. For instance, a panther in English or a dandelion might have entirely different names elsewhere, but their Latin names, Panthera pardus and Taraxacum officinale, are universally recognized. Science is a constantly evolving field, with new discoveries and technologies emerging constantly. When these new concepts need names, scientists often turn to Greek and Latin roots to create descriptive and precise terms, showcasing the creativity and adaptability of scientific language. For instance, the term microbiology combines the Greek word mikros, small, with bios, life, and logos, study. This term briefly describes the study of microscopic life forms. Another example is photosynthesis, from the Greek phos, light, and synthesis, putting together, describing the process by which plants use light to synthesize food. In conclusion, Greek and Latin are living components of the scientific lexicon, integral to scientific discourses' precision, clarity, and continuity. Whether you're studying biology, medicine, or physics, a basic understanding of these languages will enhance your ability to grasp complex concepts, communicate effectively with peers, and appreciate the rich history of your discipline.